Hello, and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of writing recursive sequences. This is standard A.12D in the great state of Texas, and we are using item number 8 of the 2024 released STAAR test. This is a new item type called drag and drop. And if you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. All right, so we have a drag and drop here. You notice that you can use each answer more than once if you really want to. And if you only select one answer, try to move on, it is going to give you a warning signal because this is a 2-point problem, so let's get both points. We have the first 5 terms of a sequence. Whenever we see this word sequence, we should be thinking, is it an arithmetic or is it a geometric? So here's the difference, and that's going to change what type of formula we're going to write here. Arithmetic has a common difference. So we are adding or we are subtracting something that's common to get from each term. And then geometric is going to be a common ratio. We are multiplying or dividing by the same number in order to get to the next term in the sequence, right? So I've got a sub 1 is 47 and a sub 2 is 33. I can't think of really any way to multiply or divide to get from 47 to 33, at least not whole numbers. So let's start with subtraction. Okay, so 47 to 33, we're taking away 14. Let's see what a sub 3 is. It's going to be 19. It does that same pattern hold? Yes, it's another minus 14. A sub 4 is 5. All right, so it's all going to hold there. It's a minus 14, and then a sub 5. Now we're negative. And that's fine. You can have these sequences that are negative. It's going to be minus 14 to get from 5 to negative 9, which means we're dealing with a common difference. It's an arithmetic sequence. Now, we need to find something that looks like this. A sub n equals blank n plus blank. All right, so how do we write this arithmetic sequence? So when we write it like this, we are going to write this A sub n, right? And what that means is that n is the nth term. So if I wanted to find the 100th term, you know what I really don't want to do? Is I really don't want to write a sub 6, a sub 7, a sub 8, all the way down to a sub 100. I don't want to do that and subtract 14. So I would rather have some type of equation here, and that's what we're looking for. So if we have the a sub n, so that's the nth term, I can find the 100th term, the 1000th term, the millionth term. What are we going to do? Well, where are we starting with? We always start with our a1, okay? So we have our a1, so we're going to start with that. And then what we're going to do is we are going to add, right? Now here's the thing. We have our n minus 1. So really this n minus 1 means if I were looking for the 100th term, I'm going to take this n minus 1, I'm going to take 99 before it because I'm going to multiply it by that common difference. And we already said our difference equals negative 14, which means if I could just start with my starting term here and then just calculate what are the 99 differences before it, minus 14, basically, right? 99 minus 14, so that would give me my 100th term. So let's substitute what we know. A sub n equals, we know our initial value is actually 47, so we can put that in there. I don't know what this n minus 1 is. We don't need to, that's fine. I do know my common difference, it's minus 14. So now we can at least distribute this out right here. So a sub n equals 47 plus, now I've got a minus 14n, and then I'm going to end up getting those two are going to end up being positive, right? This can be a 14. So 47 plus 14, that's going to make 61 plus negative 14n, or if we swap them, it's going to be negative 14n plus 61, and that's what we need. So negative 14n plus 61.